Hey guys, I'm Harshil. See a bunch of familiar faces. For those who don't know me, I've been around grad for a little while. Graduated in 2023 with Masters in Robotics and currently in robotics software at BotBuilt. Um, we're going to talk about what we do at BotBuilt, how we integrate robotics and AI to solve the construction problem, and what my experience at GRASP taught me that helps me contribute to this exciting problem. But before we get into all of that, let me talk a little about myself. Seems like this is not responding. Oh, yeah, now it is. Yeah, a little about me. So about 8 years ago, my first internship was at a shipbuilding yard. And I was amazed to know that it takes 2 to 3 years to build a cruise ship. This was in Papenburg, Northwest Germany. The first time I saw the build site, I was shocked at its massive scale, right? And very terrified because I saw an engineer hanging off the 15th story with barely a safety harness, right? And that got me thinking, wouldn't there be better ways or safer ways to get the same task done, right? Like, if anyone's seen a cruise ship outside water, 15 story more feels more like 50 stories. So it was really scary for me. Fast forward through post-COVID, I got a degree in mechanical engineering and some knowledge about power kinematics that got me into the program here. Introduction to robotics with Nadia was a really great gateway for me to do research with her. The last couple of years, those are some of the interesting projects that I worked with. The latest one being an RSS workshop paper where we got ChatGPT to work with the KUKA robot there. And then finally, I met Barrett, the CTO of BotBuilt, at a GRASP event about a little over a year ago. And that kicked things off for me. At BotBuilt, I'm doing robotics software, which essentially means everything at a robotics company. So I'm working with Isaac Simulation to do regression testing of our code base. I'm building an error handling ROS package to integrate all sort of information that we can gather from the system. And then I help out wherever necessary for operating the robots, running production teams, etc. So our mission at BotBuilt. The mission is to use the latest in technology like robotics and AI to make housing more affordable, right? And particularly in construction, we are targeting the framing aspect. So when you build a house, there's a skeleton for the house that is built with wood, and that is what BotBuilt is targeting right now before we take over construction completely. And we want to make it faster, safer, easier for people to build with, right? Why this particular problem? Well, the construction industry has not evolved for over a century. We use the same nail gun hammer tools to build with. It's dangerous. It can cost lives, right? Not only that, the unit price per house is increasing like crazy because there's a housing shortage. And half of the workforce is going to retire in the next decade, right? So the idea is with half of the workforce not available, no young people wanting to join construction, the housing prices are going to increase and go through the roof if they're not already there, right? And we want to make housing more affordable by using robotics. Here's a quick video. Let's see if it plays. Yeah, so that's BotBuilt for you guys. Honestly, if you guys have any questions throughout my presentation, please feel free to sort of ask me questions, stop me in the middle, whatever, right? Go ahead.
Do you construct them on the site, or do you just make the prefabricated?
Yeah, that's a great question. So the idea is to be able to ship the entire robotic system um, to places which are closer to sites where they can be built for multiple houses or a bigger plan. So people can choose to build them with us. People can choose to have their own robotic systems where they can be deployed at a certain location. It really depends on the builder's choice.
Okay, so I guess like for over 100 years, as you know, like companies like Sears back in the day,
Yeah.
would have house kits that they would ship to people, and then they would erect them at the site from
Right.
panels that were more efficiently made in factories. And of course, even the Empire State Building used some prefabricated stuff until it became regulated against. But so again, this is still essentially the person taking your manufactured components and assembling it at the site by hand, or if they have their own system, they assemble it. You don't do kind of soup to nuts, or we've got there.
Right. So we're not trying to focus on the assembling solution. We're trying to focus on building these individual components currently that can be assembled by these workers on site, right? And then framing can take place on site, but like you said, there's a lot of regulation involved there. You need the right weather conditions to sort of build it there. So a lot of bigger constructors have their own plants where they have manual framing, going on, and they could essentially replace those plants with a system like this. Yeah, so like our CEO Brent just briefly described the process, let me go over it again with you guys. We take any blueprint PDF of a floor plan and then turn it into a 3D model of the house. Then we optimize it for build, meaning this plan still needs to be cut down to chunks that the robots can build. So we generate a framing plan from the 3D model, right? Once we have the framing plan, we can feed that to the robots and they do what they do best, right? These panels or components come off the work table of the robots as hotcakes. We stack them up. There's a stacking order that goes to it, and then they get shipped to the worksite. Workers can just pick up the stacks and then assemble them like Legos, basically, right? And honestly, that's easier than assembling IKEA furniture, is what I feel. So yeah, getting deeper into every aspect of every step, basically. Though that's how a person would describe a house, right? And for any engineer who's seen a CAD model, we know there's an orthographic projection. It's supposed to have all the details specified in the document, right? Surprisingly, those documents are not technical documents, right? They are only there to communicate intent. And we learned this the hard way. So we got one of these floor plans, we created a 3D model, and we realized that the plan was not closed. Like there were gaps in the corners or whatever. And this was because the architect chose to round off fractions, because they're architects. But yeah, so there is a lot of optimization that goes into building the 3D model. And let me show you what that process looks like. Yeah, so this is currently a human labeling the different features that might be available on a floor plan. That can be doors, windows, toilets, walls, all the dimensions, etc. Right? So you can see they're manually labeling all this process, and you see the counter on top. It's a very painstaking process. It takes a lot of time to sort of, get the details right. And then now we run our model on top, which basically, does detection to identify the different features. Honestly, this is a very hard problem to solve because there are a lot of different features. Every builder will have probably a different legend. So your model needs to be very robust in identifying what the general features are. In fact, the dimensioning can maybe be center-aligned or not at all aligned, which is going to make it even more complex to associate those dimensions with the particular wall or window that it's talking about, right? And just see the time difference. It's going to bring down, the time and expertise required to read these floor plans pretty quickly, right? All right. So now that we've read the plan and have created a 3D model, uh, in order to build, we need to know where every nail, where every piece of wood, where every piece of sheathing, another type of wood goes into building the house, right? That gives us an accurate account of all the raw materials required. So that gets you a bill of materials for the construction, right? So that you can, preload your robots with nails or have the lumber in the right location for it to pick up, right? Once you have a bill of materials, you can get a cost estimate on how much the house is going to cost you to build it, right? If you go to a firm to figure out what the estimate of my house is and what's the raw materials that I will require, they'll probably give you a lead time of 4 weeks. So they'll require 4 weeks to sort of tell you all these details. If you come to BotBuilt, we probably do that in 30 minutes with a big lunch break. So that's saying something that this is definitely very robust and very fast. Additionally, we've noticed that builders have raw material wastage of 20 to 40% when they're building on site, right? So having a bill of materials beforehand trying to construct definitely saves them a lot of trouble in trying to procure what they need to build a house, right? Finally, there is an optimization that goes into breaking down the panel, breaking down the model into components that the robots can build. So on your right, you see something called a panel book. That's from the same house. They are from the same floor plan. The lower one is for the first floor, and the upper one is for the second floor. And you can see how simple or complex these panels can be. These definitely are technical documents, so engineers can rely on this, right? And this is the goal that the robot needs to achieve. We need to build something like that with robots, right? In order to do something like that, there's a bunch of things that go into the task and motion planning for the particular robots. So the idea is that you've got a high-level plan, which is the goal to build the panel that we saw in the previous slide, and that can be decomposed into simpler behaviors, right? So a set of behaviors like picking up wood, placing it in the right location, localizing the wood, nailing it together, cutting it, right? All these are different behaviors that can be stacked in a certain order to achieve the state we want to achieve, right? So the state meaning any intermediate position where of building the panel, right? Now, but in order to achieve a state, you need to do some action, right? So let's say you want to cut the lumber and place it in one location. In order to cut, you have some precondition. That means you need the robot to hold the saw to execute the action, right? So all these states depend on some actions to achieve that state, and then you have a set of preconditions you need to meet in order to achieve that action, right? Any questions over there, guys? Yeah.
Sure. So do you take the design as gospel, or do you do some optimization? Maybe the designer, was foolish with regard to costs, and with some minor tweaks, you could get something that's as good, but for a lot less. Does your system try and say, well, really, did you have to use this, unusual shaped part that is, that is expensive to build?
Right.
And
well, yeah. So in general, even manual panel builders need a sort of starting point to identify what they're building, right? So this can work as an input for manual framers as well, right? The only limitation here is that it's an 8-foot panel, right? Versus if you had longer lumber, you could build a longer frame with humans, right? So it's really up to the framers to define what they want to build and how they want to build it, right? And this sort of a form is easy to build both by humans and robots. So we don't go into too much detail of optimizing the number of the raw material that is used to build this. There are different codes that every state follows. That it needs to have a stud. That's one of the pieces of lumber. That needs to be 16 inches away from one another. So there are different codes that need to be followed for building residential buildings in different states. So ideally, we want to follow that and optimize for that, right? Right. So I was talking about the actions and predicates, right? So predicates meaning the preconditions for the actions to take place, so you can achieve a state, right? And schedule is nothing but stacking these actions up so that you can achieve the final goal, which is to build that panel. Now, in order to actually do the motion planning, you need to be aware of all the geometric constraints involved. We have two robots which have 7 degrees of freedom, and they have a shared workspace, right? We also have a lot of static obstacles in the environment, and as and when the state updates, the obstacle also needs to update, right? And in order to achieve such particular designs, you need specialized tooling, for which we have an in-house fabrication facility that allows us to prototype what the tool would look like, iterate over those prototypes to figure out how they can best serve the different types of designs that we have, right? So general idea here is to have information both of the panel and of the robot, use them as geometric constraints for our motion planning and task planning problems. Right. And of course, for anything to work, it needs to be validated first. So once you have these schedules or actions, you need to validate them through simulation and through other optimization techniques that sort of allow you to minimize your cost on what are the actions that need to take place for the robots to move and to achieve the state possible, right? Yeah, so I've got another quick video of the different robot behaviors that we have in place. This is the robot picking up wood from bunk using a vacuum, placing it into a measurement table, cutting it. Job site, that's where these panels go. All right. Yeah. I also work with a lot of iron hand at Grasp, so I'm really excited about this problem. Basically, you need to identify where wood is, localize it. You need, because you're manipulating this particular thing. So you need to run a detection model, a segmentation model, essentially with bounding boxes to identify wood. An interesting challenge with organic material like wood is how do you sort of classify it or identify these different states? That's something we strive to work towards, to be able to build with any sort of lumber that is available in the market, because that is going to make the system more robust at the end of the day. Yeah. Yeah, and this is a very hard tech solution to building houses, right? Because construction can be dirty, dull, and dangerous. And the idea is that you're going to face challenges and failures like you've never seen before. For example, just the nail gun getting jammed up. I call it the snake nail, and this is like a very weird error that happens probably very rarely. Even though we, oil the nail guns regularly, cycle them through pneumatic supply, these errors can still be found. Bottom center is basically a nail going for a knot. Knots are, very mischievous. They can direct a nail in a certain manner. So you want to figure out how to solve for that, which is why we need QA, QC at the end of our pipeline, right? Mid left, center up is a picture of the robots colliding. Because we were being very conservative with the collision objects of the robots. Technically, they are not colliding. It's just the tubing which is colliding with one of the other robots. But the idea is iterating over different collision objects to identify what works best when you're trying to be conservative. And the last one is just the lumber having some twist. So if you saw the last slide, you remember that the wood can have a little bend inside it. And just manipulating with it can be a difficult challenge, right? Yeah, again, we're not even talking about production here. We do production, but even to get a robot to run reliably for a demo, you need a lot of things to go your way, right? In order to do that, we have some standard operating procedures that allows us to maintain these systems, right? Because we use a lot of used robots, they have a lot of wear in their J2, J3. These robots are usually decommissioned from automotive work or from other industries, and they usually do a lot of pick and place action, which leads to a lot of wear in J2 and J3 particularly. So we try to model that, optimize for the hose, the tool changer, or the end effector will be at, right? That's an interesting problem we are currently solving. Another interesting problem is concurrent scheduling. So we've got two robots in the same space, and one is doing some task while the other either needs to wait for robot A to finish its task, and then robot B can go and execute its own task, right? But if robot A is taking longer, you want robot B to be able to cover up in some manner, right? That's what a smart system can do, right? So trying to solve for that, concurrent scheduling. Again, motion planning for two 7-DOF arms is essentially making it a 14-DOF system. We are not trying to solve it as a 14-DOF system. We are trying to sort of understand how constrained motion planning with good collision checking can, result in reduced time for motion planning. Of course, dealing with organic material like wood is what I already mentioned. Moving stacks around. By that I mean these robots are really fast in trying to frame these houses. Excuse me. So, for instance, if you go to a builder with a plan to build a house, they're going to tell you, it's going to take 7 to 14 days to build all the components for this house. We could do that in 4 hours, right? So the idea is that we need some logistical management way to move these stacks, arrange them in an order that is easy for the worker to assemble, and then have them load on the truck and take them to the job site. So moving it around, and then finally doing QA and QC, right? Like I mentioned, with the nail jutting out because of the knot, we need to understand how we can have some quality control processes using computer vision that will allow us to improve the process. Yeah.
Seems like your choice of using wood gives you a lot of extra difficulties. I mean, why not use like lightweight steel frames that are also less flammable?
Yeah, great question. So I'm not completely aware of the percentage of houses that are built in the US using wood, but they are definitely a majority in residential housing currently. Given the LFIs, maybe there is a shift in opinion about the materials that people use for building houses, but I do not have any data to substantively say that wood will or will not be phased out as a building material for houses.
But does that reflect the expense of the technology 150 years ago when balloon wood framed houses came into vogue, or does that reflect current realities?
Possibly. I mean, if we had trends discussing more inclination towards going away from wooden houses. Definitely, the technology would need an overhaul or some sort of design change that allows us to that would allow us to build for the use case. But as it stands, the market seems to be supporting wood. Yeah.
How easy would it be for you to transition from, let's say, wood to a metal frame? Like, or do you have to again rebuild your whole stack so that like you could align it with the other?
Right. I don't think we are trying to address that question right now. But if you were to just think about it, there is fundamental difference in how wood is nailed together and how steel would be put together. So there will definitely be specialized tooling involved for that particular scenario, right? So we would definitely want to work towards that if that is a requirement.
And you wouldn't use this for high-rise construct. I mean, your system couldn't be adapted for high-rise construction.
Absolutely. So if you were to break down your skyscraper into components that can be built by these robots, we can build it. Some newer stuff, which is generative AI. That's some Gaussian slats of the lumber that we've recorded. And the idea here is not to, just do it for the trend, but the idea is to capture the randomness that we saw with the computation problem, because wood can have a lot of deformities involved. So, and it's really hard to sort of classify and create data sets for this. Slats and generative AI can definitely help us capture this sort of randomness and recreate it for building our simulation, making our models more robust to different types of lumber, right? Here's a quick video of what we were doing, I think, a month ago. That's Isaac Sim with a model of one of the streams, and on the right is like a rendering splat of that particular simulation. The idea is basically the render happens real time when we articulate the arm. So that just creates a photorealistic simulation of our actual simulation. Yeah. Yeah. Recently, we also expanded to a bigger facility. We put in a lot more robots to build houses, and we also installed this remote operations command center. And it's fairly easy to operate these robots remotely. Tim there is a high school intern who's been operating robots for a little while, and you can just understand the autonomy the system is operating at when a 16-year-old can easily work with these systems. So the idea is to make the system simple enough for operators to work with, so that you don't need a robotics engineer sort of title to be able to work with them, right? Yeah, here's a quick montage of our build process. It's quite long, but the idea is we've got two robots. This is an overview. We pick up lumber from the bunks, place it where necessary, and then nail those positions together, right? This video is a little old, where we have one robot operating at one point. We currently have our system ready to deploy into production for both robots working in the same shared space, which is interesting. Definitely a very interesting problem, and we are looking forward to solving all those challenges. Yeah, but let me know if you guys have any questions. Meanwhile, yeah, go ahead, Darwin.
Is the robot fully position control, or do you have any components? Because this is like decommission from virtual, which is usually just position.
Right. Yeah. So essentially, these are all position controlled currently, and that is important because it's kind of hard to model the wear also. One, two, we have very a lot of fixed joint configurations that the robot repeatedly goes to, and just being able to control them at an easier level using that.
How do you deal with like inaccuracies? We use perception for inaccuracies.
Right, absolutely. That's a great point. So, like any ion hand manipulator solution, you need to have good calibration involved. So when we have a specialized tool, we would scan the tool, get the correct transforms with respect to the end effector, and then plan using that, right? So let's say you have a detection, you figure out where the T joint is, where you want the grippers to grab the panel that's currently being built. You need to look up those transforms, figure out where the grippers exactly need to go, given your intrinsics for the camera are right. Yeah. Yeah. That's basically the end of the process. Yeah. Any questions before I dive into this?
How do you see yourself having to recalibrate systems?
Yeah, that's a great question. So every time we have a major upgrade on the hardware, the tools definitely need to be scanned again to understand the differences. Also, manufacturing differs from tool to tool. So we scan every tool before it goes on to the tool valley where the robots can pick them up.
So it sounds like you're saying basically feeding tools only then.
Right.
Do you ever see it happen because of like, say, if you're trying to sand,
Right.
because of those impacts, do you see any calibration issues?
Yeah, that's a great question. So let's say the robot collides with something, right? And there is a huge impact, following which there can be implications on the gear as well as the tools. You want to be able to identify if that is detrimental to your production capacity, right? So the idea is to identify where the error is occurring, right? Number one, let's say, oh, you had a 3D printed camera mount that fell off, right? You will definitely need to recalibrate extrinsically your camera to for the grippers to go at the right location, right? So it really depends on error to error as to how you want to if you want to recalibrate. Yeah.
All right.
Hey.
So my question is, when you do the motion planning, it's done, or you have some sort of visual feedback? And my other question is, it seems like sequential planning, from number to number, and at some point they need to touch, right? And what happens if while placing one part, it would flip the other one?
Right.
How can it go back and fix that?
Right. Those are some very real problems that we talked about. So could you go back to your first question?
The visual.
Yeah, the visual feedback for motion learning. Well, I don't know if you noticed, but we use Move It. So that sort of gives us a preview of what the motion planning is going to look like, right? And a lot of times when the system is in development or we're developing motion planning based features, we are very careful about what sort of motions the robot is planning. There is definitely some real time planning going on during the construction process. So it's there is no visual feedback per se apart from the loop animation that Mode provides to verify the motions in real time, right? But when one operator is working with 5-10 teams, it really becomes a big task to sort of verify the motion, and that's what we don't want the operator to do, right? So these systems are autonomous enough that we do not need a visual feedback system, right? And talking about, for example, lumber falling over, right? You saw the different kinds of variations you can have in the type of wood because it's an organic material. The idea is to either filter out that prior to the process, so your detection algorithm is robust enough to filter out, not pick that kind of lumber that we have, those kind of edge cases occurring, right? So trying to be prevention is better than cure, sort of a thing. Also, if there does occur a situation like that, being able to identify that is again, error handling situation, which we're working towards right now. Yeah. I think George was before. I don't know, yeah.
So does temp directly take over from the blueprints? And is temp the only thing that happens between like blueprint to the final product?
Right. So, like I mentioned, we have a set of behaviors that go into the actions and the actions into a schedule. We have a downstream pipeline of the plans being fed to a scheduler that's gonna identify what's the best optimized way to build a panel, right? That then runs through sort of simulation validation pipeline, and then that goes to the robots, right? So there's always a couple checks involved that ensures that the robots are not doing something unnecessary or colliding. Yeah.
So the planning happens in sim first.
Well, not necessarily. The planning does happen both real time and in sim. The sim just allows us to cache some trajectories that is going to make it a much simpler problem when it actually comes to executing on the controller. Because the sim doesn't replicate the controller exactly and doesn't replicate the where and the optimization that goes on top of it. So that definitely needs to be some aspect of planning that needs to happen real time.
You predefine the predicates, right, for the woods.
Yep. So you've got some preconditions. Like for example, to nail, you have to have two pieces of lumber. You have to have the nail gun loaded. You have to have the robot holding the nail gun. All those things. Yeah.
I was concerned about the safety issue because, like as you said, these robots, they were earlier in a warehouse where you were making cars and all, so they actually have a huge net around which humans cannot go because they're pretty dangerous, and like I cannot see any kind of safety stuff around.
Right. Right.
So
Absolutely.
is there a case where, because like, and I saw a lot of people walking around.
Mhm.
So does the robot have that kind of intuition that if someone is coming, just stop the work, or like you stop it manually and then restart everything from?
Yeah, that's a great question. I think safety is primary whenever you're using such huge industrial arms. The idea is to always follow standard operating procedures for such kind of environments. So let's say you are, pausing build for some particular error that needs to be resolved with manual intervention. You would rather have the human carry the teach pad inside with you with the e-stop, or you would hit the e-stop before entering the work site, right? The idea is to be as safe as possible, and we also have risk assessment audits going on that allow us to identify what are the different tasks and hazards that people on the shop floor or operators interacting with the hardware can all the risks that they would undertake basically to do this. So you need to be we assess risk very strongly at BotBuilt about how operators or people interact with this sort of system.
I guess some folks are trying to 3D print houses, and I mean, like even going back decades, you've got people like Dante Bini doing balloon casting where you can get a steel reinforced concrete dome in like an hour or two.
Right.
So, I mean, it seems like you have a very technologically elegant system, but you're essentially working in the domain of what has been, because it was not technologically advanced,
Right.
technologically sophisticated.
Right.
In other words, you're replicating the inefficient human construction process rather than trying to do a paradigm shift. Do you see any competition with some of these other approaches, or can you incorporate them? So
Yeah, absolutely. I think that's a very interesting question. I strongly believe that for a market to survive, you don't need innovation that drastically changes it completely, right? So you want to build systems or products that allow you to integrate them well with current processes. So, for example, if you look at every process that BotBuilt goes through, there is a client that requires every aspect of it. For example, a builder just wants a build cost, or an architectural firm just wants a build cost estimate on how how much it's gonna cost the house, right? A builder just needs a panel book with the plans to build the house, right? Some builders want their their stacks to be shipped to their location, right? Some of them just want us to do QC on their houses, right? So the idea is that we want to integrate our product with the current market in such a manner that we are able to provide services to every every exit of the funnel, so that it helps the economy make housing more affordable as it currently stands. Yeah. Any more questions, guys? Go ahead.
This is actually a suggestion. I was thinking, why don't you add a step when you're cutting the lumbers? Just cut it in a way that they're matching parts, like female and male parts, and that would solve the rolling over problem. That would solve even maybe the weird shaped numbers.
Yeah, that's a great question. I think we are at a point where the system is working great, and we want to now optimize for scale, right? So you could argue that we could have a centralized location where all the lumber gets cut, and depending on whatever every team needs to build, we just ship it to that team and build that stuff, right? So there can be multiple operational adjustments to the current system to optimize for the number of teams or the number of houses or the time that you're looking to build, right? So there are different ways to optimize it, and it's an operational problem which is best left to managers who are working on optimizing these floor plans. Our primary job was to build a system that can deliver what is the final product, and then we can mix and match and move out some components, things like that. For example, you can have a system where there are 3 arms and 2 tables in the middle, and one is just assisting both while the others work, right? So there can be variations in the entire design process as well.
Yeah, I guess historically, I think in ancient Chinese housing, there was something along those lines where the wood fit together without the use of nails.
Yeah, that's Japanese.
That's Japanese.
Yeah, they have they have these joints which fit very perfectly with each other and are very sturdy as well, because they've been prone to earthquakes a lot. So there might be some way to sort of concentrate that knowledge and maybe bring that to a robotic or an AI solution that can help us build better houses. But I don't think I agree.
So, how do you feel, or how does the company feel about the risk assessment of a human one? Because really, the whole reason you're doing this is just trying to replace human and automate the process. So,
right.
But recent investment in human, it can actually pretty much maybe in the near future can replace with the human workforce,
right?
And then can probably do the same thing as what you guys trying to achieve here. So
right.
How do you guys feel about that?
Right. Well, I don't think that is a competition or a concern that we have pondered over, because just the challenges involved in building a humanoid that is dexterous enough that can hold. For example, a nail gun is like 10 pounds or like 8 pounds. Humanoids can barely lift 15 pounds, let alone manipulate that to do something like this right now, right? So it's not that it's not considered. Maybe it has a built-in nail gun to do some of the tasks that you're talking about. But the idea is that construction is dirty, dangerous sort of profession that not a lot of young people want to get into, and there seems to be a shortage of humans to do that task, right? So of course there can be solutions in the future where humanoids can do everything that humans can, right? But I, coming from a manipulator background, strongly feel that you can do the same, solve the same problem in a much simpler, way, much simpler motion planning, much simpler perception compared to just egoistic motion or egoistic perception for humanoids. It makes it a little challenging. Yeah. All right. Yeah, the last part is basically how I got to BotBuilt. I think the number one priority that I had in mind when I came to Penn was trying to make a network, because that's what Penn provides us, and try to maximize on the different types of resources that we have here, the labs, the community, talks like these, events that Gas hosts. Trying to maximize that is priority, because you will never have all this talent pool concentrated at one location, which is going to be an expert in different domains. I know I've experienced that with multiple human robot interaction with Nadia's lab. So that definitely helps develop your perspective a lot. Second is not just relying on homeworks or assignments that you do for coursework, but actually trying to implement those concepts on some real challenges. Real time is always a big challenge. Yeah, taking part in competitions, workshops, personal projects, I have personally found them to be very enriching, and I would recommend that to anyone. Solving real problems using hardware. I think that's the number one sort of thing that people are going away from. Like everyone is trying to do in simulation with AI, with some software solution that can just solve all your problems. But for them to really impact the world, you need to have some hands-on experience working with hardware. You're going to have networking issues, you're going to have calibration issues, you will have issues with noise, with uncertainty. You can't just sit back, change the covariance on a Kalman filter to expect the model to work how it should, right? You need to understand where that noise comes from, how do you model it, why it matters, all these things. So working with hardware definitely gives you that sort of an experience. Plus, for any robotic startup, you need to be well-rounded, which is not only having some specialty in, let's say, computer vision or motion planning or controls, but also being able to work with electronics, working with mechanical design, working with risk assessment audits, all these different things, right? And finally, ensuring that you have your fundamentals right, understanding what went wrong with some project that you did, not just for the grade, but understanding why it didn't work or why it works great, right? So that is something that I would like to highlight. All right, and finally, here are some roles that we're looking at for this summer. Definitely, if you're interested, please reach out to me. I can detail them if you guys want any information. Yeah, send me your resumes. I'll be more than happy to take any questions or talk with you guys more. Yeah, thanks guys.